A very good morning to all of you and my respected teachers. I am Aradhna, pursuing M.pharm first year from Pharmaceutical Chemistry in Hygiene Institute of Pharmaceutical Education and Research. I am really thankful to my teachers for giving me this groovy opportunity. Today I am going to deliver a presentation on topic heterogeneous catalyst. I am sure you will like it. So let's start. So before discussing about heterogeneous catalyst, we should know about catalyst. That what is the catalyst? A catalyst is a substance that can be added to a reaction to increase the rate of reaction without getting consumed in a reaction process. Catalyst is typically speed up the reaction by reducing the activation energy or changing the reaction mechanism. Example, enzymes are proteins that can act as a catalyst in biological reactions. Here we can see this image. Here is the present catalyst and catalyst bonding to reactants. Now, release of products and moving on for another reaction means here catalysts are separated. Now, types of catalyst. First is homogeneous catalyst, second is heterogeneous catalyst. What is that? Homogeneous catalyst, catalyst in same phase as reactants. And heterogeneous catalyst, catalyst whose phase differs from that of reactants or product. Example, solid catalyst in gaseous reaction. Here topics are given which we will cover in this presentation. First is introduction, preparation, characterization, kinetics, supported catalyst, catalyst deactivation and regeneration. Example of heterogeneous catalyst used in synthesis of drugs. Now, introduction. Catalyst in different physical form from reactants. It is also called contact catalyst. It possesses great industrial importance. It works in 3 steps. First is adsorption, second is reaction, and third is desorption. Now let's talk about the first step, that is adsorption. What is the adsorption? When incoming species lands on an active site and forms bond with the catalyst, it may use some of the bonding electrons in the molecule, thus weakening them and making a subsequent reaction easier. We all know that reactants act on active sites and they form bond with catalyst. Now step second, that is reaction. Adsorbed gases may be held on the surface in just the right orientation for reaction to occur. This increases the chances of favorable collision taking place. In this step, reaction process start on the surface by the collisions. Now the third step is desorption. There is a rearrangement of electrons and the products are released from the active sites. This is the last step where our products forms and catalyst gets separated. Here are some examples of heterogeneous catalyst. Gaseous phase, liquid phase and solid phase. Now let's talk about the preparation of heterogeneous catalyst. Contemporary solid catalysts are rather refined and sophisticated material derived from commercially available chemicals. The variety of such chemicals for the preparation is quite wide. Indeed, of some catalysts can be prepared by many different routes, but in general, some general elementary steps or operations have to be followed. These steps or operations are based on two approaches. First is detailed knowledge of scientific laws which govern chemicals and physical transformation based on fundamentals of inorganic or solid state chemistries. Or second, empirical observation related to carefully guarded know-how. Now let's talk about target for catalyst preparation. First is activity, selectivity, stability. Under the stability, cooking, poisoning by reactant, sintering, poisoning by impurities. Morphology, mechanical strength, resistance, thermal properties, regeneration, reproducibility, not patent or patentable, or and last but not least, that is cost. Here are given some types of heterogeneous catalyst preparation. First is preparation of bulk catalyst. Second is preparation of supported catalyst. Third is oxide catalyst preparation. Fourth is metal catalyst preparation. Fifth is acid base catalyst. First, preparation of bulk catalyst. Precipitation method, P sol gel method. See other methods. In other method, hydrothermal synthesis. Second is flame hydrolysis, and third is other methods. Under the preparation of supported catalyst, we can see simple impregnation and wedge co-impregnation. Third, oxide catalyst preparation, single oxide, mixed oxide. Fourth is metal catalyst preparation, reduction of oxide, unsupported metal catalyst, and C is supported metal catalyst, and fifth is acid base catalyst. Now let's talk about in brief about step followed in preparation of heterogeneous catalyst. First, precipitation or gel formation from starting materials. Then decantination or filtration. After filtration, we can wash it. Then dry. After drying, crushing and grinding, forming, then calcination, impregnations, and final activation. Here are given some specific methods to prepare solid catalyst. First is precipitation, second adsorption and ion exchange, then impregnation and dry mixing. Now let's talk about impregnation method, which comes under supported catalyst preparation. Impregnation, also called capillary impregnation or dry impregnation, is a commonly used technique for the synthesis of heterogeneous catalyst. Typically, the active metal precursor is dissolved in aqueous or organic solution. Then the metal containing solution is added to catalyst support containing the same pore volume as the volume of the solution that was added. Capillary action draws the solution into the pores. Solution added in excess of the support pore volume cause the solution transport to change from capillary action process to diffusion process, which is much slower. The catalyst can then be dried and calcinated to dry off the volatile components within the solution, depositing the metal on catalyst surface. The maximum loading The maximum loading is limited by solubility of precursor in solution. The concentration profile of impregnated compound depends on the mass transfer condition within the pores during impregnation and dry. Here are given some type of method of impregnation: dry vacuum pressure impregnation, wet vacuum pressure impregnation, wet vacuum impregnation. Now, characterization of heterogeneous catalyst. First is specific surface area meter square per gram or centimeter square per gram, which it is the sum of the external and internal surface area. Second is specific porosity, the accessible pore void space per unit mass. Third is pore shape, which is difficult to describe except in cases of regular structure such as zeolites. Fourth is pore size distribution, the distribution of the pore volume versus the pore size. Fifth is mean pore size, either the pore size distribution or the specific porosity, in which pores are divided into three categories: macro, meso, and micro. Six is shape and size of agglomerates of particles, for example, pellets, granules, and extrudates. Now, deactivation of heterogeneous catalyst. Loss in catalytic activity due to chemical or mechanical or thermal processes. Heterogeneous catalysts are more prone to deactivation. Here are given a column in which mechanism, type, and brief definition of or description are given. Now, regeneration of heterogeneous catalyst. Regeneration procedure. The spent catalyst was solvent washed with heptane at 100 degrees Celsius to remove excess wax. Second, the catalyst sample was subsequently subjected to a calcination, example oxidation step in a fluidized bed calcination unit using an air by N2 mixture and the following heating program 2 degrees Celsius per minute to 300 degrees Celsius 6 to 8 hours, hold at 300 degrees Celsius. The oxygen concentration was gradually increased from 3 to 21% O2 or N2 to control exotherm. The oxidized catalyst sample was subsequently subjected to reduction in pure hydrogen in a fluidized bed unit using following heating program: 1 degree Celsius per minute to 4 to 5 degrees Celsius 1550 hours, hold at 425 degrees Celsius. The reduced catalyst was loaded into wax. First is dewaxing, oxidation. Third is reduction. Here are given regeneration of cooked catalyst. Now, application of heterogeneous catalyst. Some reported application of heterogeneous catalyst are presenting below. First is effect of hydrogen presaturation of catalyst in hydrogenation of olefins. Second is synthesis of pyrimidine and pyrimidine derivatives in presence of high surface area magnesium oxide. Third is synthesis of dihydropyrimidine, pyrimidinones, and practical synthesis of monosterol. Fourth is a simple, economical, and efficient Friedel-Crafts acylation reaction over zinc oxide, means zinc oxide, and Hague reaction and cyanuric acid synthesis by heterogeneous catalysis. Synthesis of amido alkyl 2 naphthols under sonic condition. Now, conclusion and outlook. In recent years, the use of heterogeneous catalysts has received considerable interest in various disciplines, including organic synthesis. Their advantage over their homogeneous counterparts due to the prime advantage that in most of the cases catalyst can be recovered easily and reused. In this context, use of heterogeneous catalyst is especially appealing in view of the fact that the reaction procedure is simple, environmentally benign, eco-friendly, and the diversity can be readily achieved simply by varying the reacting components. Thank you.